Assalamu alaikum, welcome everyone, and we'll continue the linear array series. And before I continue, I have this shift right array code over here. We didn't do it in the last video, so I put the code over here. It's working perfectly. I have checked it, so if you need it you can use this one. And one more thing is, don't try to use these codes on your lab work or exam. Try to change it a bit. And I have used object over here. You may have integers, you may have double, so it is important that you read the question carefully and use that data type and integers, or and in 220 questions there are sometimes some extra activities. For example, they may tell you to check if there is any space left, check if it can be shifted, check if the index is empty, stuff like that. So it's very important that you read the questions before you answer, and only coding and only learning how to do this will not do. You need to have the basics. So that's a minute introduction speech. So let's continue to insert. And this is not just any insert. You will have to insert an element on a given index of the array. So normally we insert an value in an empty box in an array easily, but this is not like that. You have to insert the array in a given index. So it is possible that there is an array and it maybe it is of index up to, it has index up to 9, and you'll have to insert the element at index nong 6. So it's like this. So what the alarm? Okay, shut down the alarm. So now let's start before doing anything else. So first thing we need to do is we need to check if the array has a space for inserting an element. So that's important. So first thing is we need to check, we have the size already, so we just have to check if the size is full or not. So if size is greater or equal this is the array and its length. Cool. Now you can print whatever you want. Let's just say no space left or something. So this will just return. Oh, I have made the method void, but oops, sorry. Sometimes the teacher may tell you to return true or false. So if in this case, if it's such that you have to return a boolean value, you will be returning false over here. But we're not doing that since my method doesn't return anything. Now it's the main thing. Let's do one more thing. If the index is invalid, then we'll have to say that's an invalid index. So let's go ahead and do that. Same thing again, because you can never have an index which is greater than the array length. You can print something. I'm just too lazy, so I'll just copy this and index error. Much better. So we have two problematic conditions. One is if there is no space left. Another one is if the index is invalid. Now all that remains is the insert. There are 3 steps to do this thing. Before writing, let me tell you the steps. First thing is start the index from the size where the space is left. Second step is shift the elements from that index. Third step is put the element in that index. If you don't understand anything, you will understand things after I finish this. So let's just have st, which is the starting. Of course it will be array length minus size. You see this size came from over here, which shows us how many elements this has. so it was given to us. There are methods to determine size. If it's not given, you may have it in your mid. We'll start from the length minus SC. Now why are we doing this? Because we need to shift all the values that are now at present condition by one index, because we will insert in the index which is given over here. But if we insert the value now, one of my values will get lost. I can do that. So first thing is I need to shift and make that space empty, and then I need to insert it. So first thing is making the space up. So we'll continue until the index is smaller, and of course it's a reverse shift, so we'll do this increment. Now you tell me, what do we have to do here? I told you that we have to shift the elements. So we have started from the end, kinda. Now all I have to do is, in that index I'll have to put the value in the previous index. So I'm actually bringing the values from the left to the right, and this loop will continue until it reaches the limit. After that, now I have my space, so now I can go ahead and input the value in that index, no problem. And I'm also told to tell you the size after the insertion. So that should do the trick. This is a notation for the success of the insertion. If you're given a Boolean method that requires to return a true or false, so you will be returning true over this condition. That's our insert code. I think it's complete, and check up the index, and now we'll test this. Compile error. Oh, of course. You can't have two else ifs, you need one else. So, oh, it will be ARR. See, I make silly mistakes. Oh man, never ends. So, since we are ready, we'll start it. One more thing, here, we'll start from array length minus 1. We will not start from array length minus ST. That was wrong. So now this thing will work. And now let me tell you what we did. We are told to insert an array in a given index, and we are also given the size of the array. Here the size is not the length of the array. Size is actually the number of elements available. So if you just check the size with the array length with the availability, then you can just check you can easily check the availability of space. So we did that. If the size is greater, then we said that there is no space left, or if the size is equal. The greater is not actually valid. So if the size is equal, we said there is no space left. If the index is bigger or equal to the array length, then the index is invalid as well. So these two things are easy to check, right? And if these two conditions are not faced, then what we'll do is we'll take ST from which we'll start, and first thing to note is that, like I said every time, we need to shift the arrays, the elements, from left to right. So if even we have one index left which is empty, and our index starts from 0 and ends at 9, and the index now 8 is empty, and I want to insert an element at 4, then I'll have to take all elements from 4 to 8. These 4 elements must be shifted right. You already know how to shift elements, so we'll do that. And this thing is unnecessary, we don't need this. So for that, a simple thing to do is start from I, the last index of course, and then pull the elements until you reach the index, which is the index we need to insert the element at, and then keep replacing the values. Once the values are replaced and you reach index, now you have duplicate values at index number 4 and index number 5. So you put the element in index number 4 and there's no problem, it's done. So that's easy. Now let's do. I wrote 3 and 4 extra lines which was unnecessary, so I removed them. Now the code looks fine, just fine. I hope it works. So this is the result, and this is the insert method where you have an index up to 6, from 0 to 6, and I have told the method to insert something at the size is 3. Actually here the size is 6, so just for test purposes let's write 6. The size is 6, and now we'll have to put the element 6 on the index num 3, which is over here. So if we shift these elements, we'll have to shift this 3. 400 should be here, 500 should be here, and 600 should be here, and the 0 should be gone. So shall we give it a try? Which already happened though. See, now the size is 7, so this is the correct thing. 663, the size is 6, and now after the insertion the size is 7. Now if you put 7 over here, they will tell you that's an error, no space left. See, not to mention, and if you give an invalid index but the size is fine, it will still give you an error. Ta-da, index error. The print is happening of this method because of this method. So we're done with insert. That's all for insert. And now we have rotating and remove, and then we're done with linear arrays. So let's get to the point. Let's start with remove, or should we do rotating? Now there are 2 types of removing. First thing is to remove a single value, and then there's the thing to remove all elements. In your lab of 220, you'll be told to remove all elements. So let's do that. Okay, so let me tell you one interesting thing. Before we go to remove all, how about we do remove from a specific index? Don't you think it will be very similar to this method? What change do we have to do? In this method, in a certain index, we insert a value and then shift all the values. What if we need to remove a value from a given index? Then all we have to do is do the reverse. Then we'll have to shift all the values towards the left where the value is removed, and the last value, last index, will have a value of 0. Isn't that just the reverse of this? So to do that, why don't we just modify this method? So let's go ahead and copy this. Here you go. We're gonna rename this to remove. We will need an array, we don't need the size. Then again we can use the size to see if it's already empty. We don't need the element because we're gonna remove it anyway, so no point of getting the element. So here if size is, less than 0, less than or equal to 0, let's just write invalid function. Sounds so programmatic. So, and this will remain the same. If the index is weird, then it will show an index error. We don't have to change those things. Now here's the main thing. We started from the last index, we pulled the values from left to right, and then once we reach the index we put the value there. Now we will have to do the reverse. Where will we start from? The index where we are supposed to remove the value, and this will no longer be this. We'll have to continue until we reach the length -1, and then we'll have to increment this. So this is simple enough. If you don't understand what we are about to do, we're going to start from the index where we are supposed to remove, and we're going to pull back all values from the right towards the left. When we did insertion, we did the opposite. From the right, we pull the values from left to right. So let me show you. When we were about to insert, we took, if we wanted to insert here, we sent 300 here, 400 here, 500 there, and 600 there. But now we're going to remove 300, so we'll bring 400 over here, 500 over here, 600 over here, and 700 over here. So that's the reverse of what we are going to do. So we change the loop, and now here we're not going to pull from left to right, we're going to pull from right to left. So that's the way to do this. And once we are done with this, we'll put 0 in the last index, otherwise they'll show similar values. So we are not doing any kind of insertion, we are doing removal. So I think that's it. Now let's go compile, and the error is bound to happen. So it says that okay, so the values differ in length. We need to give a size. So let's just say it's 6. And now what I'm trying to do is we're going to remove the third index value, which is this 0, 1, 2, 3. So 400 will be removed, and 500 should be here, 600 should be here, and 700 should be here. So let's go ahead and do this. Let's run the program. Oh, it worked like a charm. 400 is removed, 500 is pulled, 600 pulled, 700 pulled. And if I didn't do this part of putting the last index into 0, then there would be 2 700s, which is wrong. So there you go, that's all. And if you want to remove all the values, then you, in this loop, will start from index 0. Okay, let's just do that. Though it's not necessary, let's just do that. Everything will remain same. Let's remove this stuff, we don't need these. There will only be one function. We don't need the size. Remove all. It will start from 0, will go until the array length is reached, and all the array i's would be replaced with a 0. Beautiful. But in case of object, 0 is still something, so it's better to replace it with null. Now we need to check this method works or not, so let's put remove all over here, and let's see if it works. null, 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 and there's 700 over there. Now why is that? Let's see. Shouldn't be like this though. Let's check this. There we go. When we were doing removal of a certain index, we still needed to keep the last index free. So that time we needed to reduce it to array length -1. But when we are removing everything, we don't need that. So we need to go all the way to array.length. Or if we put array length -1, then we'll have to put an equal there. So it's the same. Now we have one final thing to do, which is called rotate. Now there are two types of rotate left and rotate right. So public void, no, it's not void, it's probably return. I'm writing return here. An object array. Now you have to write an object return the array if they tell you to return the array after you are done with the rotation, which is complicated. In your lab you don't have to do that. So let's just keep it void for now. If you need to do it in your lab, then I'll show it to you. It's just you will have to put the array in another array and then you'll just return that array. So it's easy. It's nothing new. So shift left. Here will be given an array of object. Hey, we did shift. Sorry. Rotate. Will be given an object array or an int array, whatever, it's the same. Let's put it R. And a number, that's the amount you need to rotate. And after you're done with this, you need to return the array. So this is the thing. Now we're going to rotate left and then we're going to do the same thing for right. We did the left of shift. Right and left is almost the same, but I think I should show you the right of rotate. Since we did the left of shift, I'll go with the right of rotate. So it will be rotate right. The things required are the same. Now, what do we have to do? First thing is, if you want to rotate something, you'll just have to change the elements and rotate them. How can I explain this? I'll give you an example. Once we are done with this coding, I'll show you what actually rotate is. But you probably know what rotate is, right? It will be 1T. You already know what rotate is if you have attended it in your class. So let's just show you how it's. And one thing I should tell you is that rotating is not so important. But still, I'll show you a very, very, very quick way to rotate. It only works when the array has even numbers of, even numbers of length. And actually rotating makes sense when there are even numbers, because if you rotate an array, for example, let me remove this. If you rotate this array by 3 values, then these 3 values should be over here and these 3 values should be over here. So there will be a flip of 3 values on the array. That's what rotate is. So another thing you're noticing is if we do such rotation, then rotating would be same for left and right. I'm only going to show you a simple rotate because it's, like I said, it's not so important. So let's go ahead. At least it's not important in linear array. We may do details of it in circular one. So you take an X, which is like a temp actually. You can name it temp for your own good. and an ordinary x as usual to do the work of indexing. We're going to use a while loop here to keep things simple. Alright, so while this x is less than k, now which is k over here, this value, so until x reaches a value which is the amount that you need to rotate, we have this loop basis, and since the temp let him do his work, he will be storing the value of the r and the current value position of, oh, it's not y anymore. So understand that here we are going to put the value which is the first value after the rotation value on the temporary file so that it doesn't get lost, which means we're going to replace that value with the actual value that is existing at x now. So you can understand that here actually now 4 is being replaced with 1, 5 will be replaced with 2, and 6 will be replaced with 3. That's how it's done. Now do the reverse. Replace that 1 with the value you stored from the 4th index, which is now 10. So you did that. Now don't forget to add the y increment. Why am I writing y? It's x. I'm used to using y, so pardon me for that. Do you understand what's happening now? Now when the while loop is over, we need to just return the r, and it's done. So that's for rotating it right. If you want to test it, let's go ahead and test this one. We need an array and a k. So we need an array x, and let's keep it simple by 3 indexes. You know, right? To keep things simple. And we are always getting compile errors, which is nothing new. I put an extra bracket over here, which is not necessary. Now it will work. So they're showing another error. You cannot convert it into, okay, so to make things simple, let's just make this an int, and also this will be an int, and this will be an int as well. I'm tired of this things. Still it's showing an error because I didn't give any data type. So compile. One thing I do is I fix the errors over here, because so that you know errors will happen. Don't just like kick your PC or break your monitor because you have this yellow. I know it, how much it annoys you, but still we'll need to. It's better if we just try to read what's the error. Look, in this video, in this linear array series, I can count how many times I have to see that yellow. Maybe I will still have to see it. Look, I told you. It never ends. But better to just read out the error and solve it. And then when you get this compiling success message, that's something else. That's peace, Now we can test it. So all we need to do to test is just run, and let's see if it runs. And look, 100, 200, 300, 400, 500, 600. Successful rotation of the array and successful completion of the linear array series. Rotate left, you can do it yourself. and rotation is once again not important. So let's give a quick review of what we did in linear arrays. First thing we learned is how to do printing. We replaced it with int, and it doesn't matter, the algorithm is the same. So you take an index and you print out until you reach the final value. You can modify your printing as much as you want. I have not done ordinary printing over here. I did some changes. You can also use the enhanced for loop, but it is better to do it with the main for loop. You can resize an array by creating a new array and then putting the values of the previous array using the loop and continue it until the old array length, so that it replaces the values and then the rest will remain 0. So you don't have to do anything with that, because you are just told to resize, so it's done. Then we did reversing the array. So we took a new array and we replaced the values reversely using this algorithm, starting from the back and pushing that array in the front, and that's how we did that. We need a new array for this. So if they tell you to return the array, then you can just return the array you created, and that's the way to solve this one. Shifting left and shifting right is almost the same. Just a few minutes of work. The amount of full you want to shift, the amount of numbers, you just need to start from there and then do the shifting. If it's right, you have to do in the shifting right, and if it's left, do the shifting from left. That's kind of reverse of each other. For example, you start from the back over here and you start from the beginning over here. So we showed that. Insertion is a complicated but yet easy process where you just shift the elements on the right, and then once the index is ready, has a duplicate value with the next value, you put the value in the given index and it's done. And you need to do some checking before you do that. And remove is the same as index, even easier. All you have to do is do the shifting left this time and just replace the last index with 0, otherwise it will have duplicate values. And removing all is even easier. Just do the printing, and instead of printing, replace it with null. We didn't do rotate left, we did rotate right, which I showed you, which is just 5 lines of code, easier. I made it myself. And then we created a class. This is 111 concept. We had an array and then we used these methods to do that. So that's all for linear arrays. In the next one video we'll be doing circular arrays, and then we'll move on to linked list quickly, inshallah. See you then.